So you've done it, you've built the whole agent. It has instructions and tools and memory. It can plan, coordinate a team, and it's wrapped in guardrails. You type in a few test questions and they all come back looking great. So ship it, right? Well, hold on. Because you tried it a handful of times and it seemed fine. But seemed fine is not the same as is good. What about the thousands of inputs you didn't try? The strange edge cases, the rude user, the confusing request, the question you never thought to ask. A few good demos tell you almost nothing about how the system behaves at scale. And it only gets harder from there. Say you ship it and it genuinely works. Then next week you tweak one line of the prompt to fix one small annoyance. Did that innocent little tweak quietly break 5 other things you weren't looking at? You have no idea. Then the underlying model gets updated by its provider. Is your agent still as sharp as it was, or did it silently get worse overnight? Without a way to measure, honestly, you are just flying completely blind and hoping. So this final piece is about replacing hope with knowledge, 2 disciplines that turn "I think it works" into "I know it works, I can prove it, and I'll know the instant it breaks." Evaluation and observability, testing and monitoring for AI. This is the evals and monitoring block from my video on agentic design, and it's the finale of this whole series, the piece that makes every other piece trustworthy. How we measure an AI before and after we ship it. Let's build it piece by piece. Part 1, 2 questions. This whole topic comes down to answering 2 deceptively simple questions about your agent at 2 different moments in its life. The first question you ask before you ship, is it good? Have I actually measured on a wide range of realistic inputs whether this thing does its job well? This is the world of evaluation, or evals for short. It's how you earn the confidence to launch at all. The second question you ask after you ship forever, is it still good? Now that real users are hitting it in ways I never imagined, is it holding up? Is it failing anywhere? Is it getting slower or more expensive or drifting? This is observability, watching the living system out in the wild. And together these 2 are that final block from my agentic AI video. The one labeled evals and monitoring, sitting a little apart from the rest, watching over everything. It's easy to treat it as an afterthought. It is, in truth, what separates a real product from a fragile demo. Measure before, monitor after. It sounds a lot like testing software, and it is in spirit. But testing an AI turns out to be a genuinely different and harder problem, and we have to understand why. Part 2, why this is hard. If you've written normal software, you know how testing works. You call a function, you check the answer. 2 plus 2 should return exactly 4. If it does, pass. If it doesn't, fail. Crisp, certain, black and white. AI shatters that comfortable picture in 3 ways, and each one takes away a tool that traditional testing completely relies on. First, the answers are open-ended. Ask the agent to summarize a document, and there is no single correct summary. There are thousands of good ones and thousands of bad ones, and no exact string you can check against. You can't just compare to the right answer because there isn't one. Second, quality is subjective. Was that summary good? Well, that depends. Was it accurate, clear, the right length, for the right audience? Judging it isn't a simple equality check. It's an act of judgment, the kind of thing a thoughtful human does, not a line of code. And third, it's non-deterministic. Here's the one that really breaks people's brains. You can send the exact same input twice and get 2 different answers. The model has a built-in element of randomness. So even a test that passed a moment ago might fail the next time you run it, through no change of your own. Open-ended, subjective, and non-deterministic. Every one of those makes AI resist the simple, certain testing that normal code enjoys, so we need a different toolkit. Let's build it, starting with evals. 3, the test set. The foundation of any evaluation is deceptively simple. It's a collection of test cases. Think of it as an exam you write for your agent and make it sit over and over. Each case has 2 parts, an input, a realistic request the agent might actually receive, and some notion of what a good response looks like. Sometimes that's an exact expected answer. More often, it's a description of the qualities a good answer must have. A few hundred of these cases become your exam. And the single most important property of that exam is that it's representative. It has to look like the real world your agent will face. The common everyday requests, yes, but also the tricky edge cases, the ways users misbehave, the awkward inputs that break things. A test set of only easy questions gives you a dangerously flattering grade. So where do these test cases come from? At the start, you write them by hand, the obvious requests plus every tricky case you can dream up. But the best cases, as we'll see, come from reality itself, the real questions real users ask, especially the ones your agent got wrong. A good test set is never really finished. It grows, case by case, sharper every month. So you have your exam, a big set of realistic inputs paired with what good looks like. You run the agent on all of them and get an answer for each. Now comes the hard part. For every single one you have to decide, did it pass? Part 4, grading the answers. This is where we confront that open-ended, subjective problem head-on, because grading hundreds of free-form AI answers is itself a serious challenge. There are 4 main ways to do it, on a spectrum from rigid to flexible. At the strict end, exact match. Does the answer equal the expected string precisely? This is fast and perfectly reliable, but it only works for the rare cases with one right answer, like a yes or no or a specific number. For open-ended text, it's almost useless. Softer rules and checks. Not a perfect match, but does the answer contain the key fact? Is it under the length limit? Does it avoid the banned words? These heuristics catch a lot cheaply without demanding a single perfect answer. Useful, but they only scratch the surface of quality. At the flexible end, human review. A person reads the answer and judges it. This is the gold standard. Humans understand nuance, tone, and correctness in a way nothing else does, but it's slow and expensive and doesn't scale. You cannot have a human grade 10,000 answers every time you change a prompt. So there's a 4th way that's become essential. The AI judge, the very same idea from the guardrails video. You use a separate model to grade the answers. You give it the input, the response, and your definition of good and ask it to score. It's not as wise as a human, but it's fast, cheap, and scales to millions. Most modern evals lean heavily on it. So we can grade at scale, mixing cheap rules with a scalable AI judge and humans for the cases that matter most. But a single pass or fail is a crude verdict. What are even grading for? Part 5, what to measure. It's tempting to reduce everything to one number. Did it get the right answer? But a truly good agent has to be good along several dimensions at once, and a series of evaluation tracks all of them. There's task success. Did it actually accomplish the goal you gave it? There's quality beyond merely being correct. Was the response clear, well-formed, and appropriate for who was asking? There's safety. Did it stay neatly within the lines, or did a guardrail have to step in and catch it? And then there are the hard, practical costs. How much money did generating that response actually burn, and how many seconds did the user sit there waiting for it? And these pull against each other constantly. A slightly better answer might cost 3 times as much or take twice as long. A safer agent might refuse more often. There is rarely a single best. There's a balance chosen for your particular product. Ring every dimension is what lets you see the trade-offs clearly and choose on purpose, instead of by accident. So a good eval is a rich report card across success, quality, safety, and cost. And once you have that report card, you can do the single most valuable thing in this entire discipline. Part 6, catching regressions. This is the payoff. The reason all that eval effort is worth it. And it solves the exact nightmare we opened with, the fear that fixing one thing silently breaks another. Here's the practice. Every single time you change anything, a tweak to the instructions, a new tool, a swap to a newer model, you rerun your entire eval set and you compare. Did the overall scores go up or down? Did any specific case that used to pass suddenly start failing? Last one has a name, a regression. Something that used to work and now doesn't because of a change you just made. Without an eval set, regressions slip through completely invisible and your users discover them for you. With one, they light up instantly before anything ever ships. You catch your own mistake in private. And this utterly transforms what it feels like to improve an agent. Instead of nervously changing a prompt and quietly praying you didn't break something you can't see, you make the change, run the evals, and simply watch the result in hard numbers. Overall quality up 2% and not a single case regressed. Ship it with confidence. It turns what was terrifying, superstitious guesswork into calm, measured engineering, the difference between hoping and knowing made routine. So evals let you launch and keep improving with real confidence, but the moment your agent meets real users, you enter a world your test set could never fully capture. For that, you need the second discipline. Part 7, Watching the Live System. Your agent is out in the world now. Real people are using it in real, messy, unpredictable ways. Evals told you it was good in the lab. Observability tells you how it's actually doing in the wild, and its first essential tool is the trace. A trace is a complete recording of everything the agent did on a single run, not just its final answer, but the entire journey, what it was thinking, which tools it called with what inputs, what each tool returned, every step of that think, act, observe loop captured in order. It's the flight recorder for your agent. And the moment something goes wrong, and eventually in production, something always does, the trace becomes priceless. A user reports that the agent gave a bizarre, nonsensical answer. Without a trace, you're reduced to guessing what happened inside that black box, trying to reproduce it blind. But with the trace, you can replay the entire run, step by step, and watch the exact moment it went off the rails, the bad tool call, the misread result, the one wrong turn that spoiled everything after it. This is the debugging superpower we first met with multi-agent systems, now applied to absolutely everything the agent does. So a trace lets you understand any single run in perfect detail, but you'll have thousands of runs, then millions. You can't read them all. To watch the whole system, you have to zoom out. Part 8, The View from Above. A trace shows you one run up close, but to understand the health of the whole system, you need the aggregate view, the metrics, the big numbers gathered across every single run and watched over time. These are the vital signs of your live agent. What fraction of tasks are succeeding? What's the average cost per request, and is it creeping up? How long are users waiting? How often are the guardrails firing, and are the failures suddenly spiking? Each of these is a dial on a dashboard, and a sudden move in the wrong direction is an alarm that something has broken right now in production. There's one more stream of signal, the most valuable of all. Feedback from actual users, the thumbs up or thumbs down, the reported bad answer, the frustrated correction. These are real failures from the real world that no test set ever anticipated. They are pure gold because they show you exactly where your agent is falling short in practice. This closes a beautiful loop. Those real-world failures caught by observability don't just get fixed and forgotten. Each one gets added as a new case back into your eval set, so the exact mistake can never silently happen again. Your agent gets tested against reality, and every failure it survives makes the exam a little wiser. Observe, learn, evaluate, improve, and around again. Evaluation before, observability after, and a loop that carries lessons from the wild back into the lab. We've built the final block, and with it, the entire system is complete. Let's step all the way back. So here is the last piece whole, before you ship evals. A representative exam graded by rules, by humans, and by an AI judge measuring success, quality, safety, and cost, and catching every regression before it reaches a user. After you ship, observability. Traces to understand any single run, metrics to watch the whole fleet, and user feedback flowing back to make the next exam wiser, measure, monitor, and learn forever. And with that, step back and look at everything we've built across this entire series. It started with a single model that just predicts the next word. We learned to steer it with prompts and context. We gave it a job with instructions, hands with tools, knowledge with retrieval. A past with memory, a strategy with planning, teammates with multi-agent systems, safety with guardrails, and now proof that it all works with evals. Block by block, a word predictor became a system you can actually trust. And if there's one thread through all of it, it's this. Not one of these blocks made the underlying model any smarter. The raw intelligence was there from the very first video. Everything since, the context, the tools, the memory, the plans, the teams, the guardrails, the evals, was about wrapping that intelligence in structure until it became reliable, safe, and genuinely useful. That is what building with AI actually is. Not summoning intelligence, but engineering around it. And that's the whole blueprint, from a single predicted word all the way to a complete, trustworthy agent that you can actually hand real responsibility. Thank you genuinely for building it with me all the way to the end of this series. It's been a real journey. If it helped the whole picture finally click into place, give it a like. It truly helps the channel grow. Subscribe because we are far from done. Next, we go deeper still inside the model itself, with how language models are pre-trained, how they're fine-tuned, and the ideas that make them work at all. We're building AI up from the ground, one blueprint at a time. Thanks for being here. See you in the next one.